Hello everybody, in this section we're going to be talking about conditional statements. A conditional statement is a statement that can be written in the form if P then Q. So if one thing happens, then another thing happens. If then statements, you can also call these conditional statements if then statements. It's written in the form if P then Q. Okay, and there's the notation, P arrow Q, and it's read if P happens, then Q happens, or you could just say P implies Q. Hypothesis. Hypothesis is the phrase immediately following the word if in a conditional statement. Conclusion. Conclusion is the phrase immediately following the word then in a conditional statement. Okay, here's an example of a conditional. Here's the notation for it. If P then Q, P arrow Q. There's the hypothesis. There's the conclusion. Okay, here's our example. If two angles have the same measure, then they are congruent. The P, or the hypothesis, if two angles have the same measure, and the Q is the blue part. They are congruent. Now here's what we call the converse. The converse is when you switch around the hypothesis and the conclusion. Notice the order we're saying that. If Q, then P. So let's say our statement again in the reversed order. If two angles are congruent, then they have the same measure. Next we're going to talk about what's called the inverse, and that's when you put a negation in front of the hypothesis and conclusion. So if two angles do not have the same measure, then they are not congruent. That is the inverse of our original conditional statement. Then there's the contrapositive. Now that switches absolutely everything around. It puts negation in front of each thing, and it switches around the hypothesis and conclusion. So here's the statement. If two angles are not congruent, then they do not have the same measure. So here's all four of them again. If two angles have the same measure, then they are congruent. That's our conditional. Here's the converse. If two angles are congruent, then they have the same measure. Here's the inverse. If two angles do not have the same measure, then they are not congruent. And then finally, here's the contrapositive. If two angles are not congruent, then they do not have the same measure. Here's some more examples, a different statement here. If two angles form a linear pair, then they are supplementary. Here's the converse of that. If two angles are supplementary, then they form a linear pair. Notice the hypothesis and conclusion were just switched around. Here's the inverse. If two angles do not form a linear pair, then they are not supplementary. Here's the contrapositive. If two angles are not supplementary, then they do not form a linear pair. Now we can assign truth values to all four statements. They may be true, they may be false. Let's look at the first one. That is a true statement. If two angles form a linear pair, then they are supplementary. That's true. But the converse is false. If two angles are supplementary, then they form a linear pair. Now, you don't have to be supplementary to be a linear pair. You could be two separate angles, not next to each other. The inverse is also false. Two angles do not form a linear pair, then they are not supplementary, for the same reason I said the converse. The contrapositive, though, that is also a true statement. If two angles are not supplementary, then they do not form a linear pair. Okay, notice the conditional and the contrapositive have the same truth values. The converse and the inverse have the same truth values. True or false, though, that's always going to be true. Conditional and contrapositive, same truth values. Converse, inverse, same truth values. The last one we'll talk about is what's called a biconditional statement. A biconditional statement is the conjunction of a conditional and its converse. Okay, so if a conditional and its converse together are both true, then basically you can flip the order in which you say them. And it states here, if P then Q, and if Q then P, then P implies Q if and only if. If P is true if and only if Q is true. You can go back and forth. It doesn't really matter what order you say it.